I'm Edie Lush, executive editor of Hub Culture. It's Davos. It's 2026. We are outside. I'm delighted to be here. Dr. Ariel Ekblaw, how are you?
Thank you. Thrilled to be here myself.
Fantastic. So you are the CEO of Aurelia Institute, GP of Aurelia Foundry Fund. Tell me, we are going to talk about space.
Indeed.
I love it.
Thank you.
You talk about investing across the whole space stack.
Yes.
What does that mean?
So we think about everything from the infrastructure that enables things like satellites, telecom, GPS, where it runs our phones day in, day out, all the way to the infrastructure for space stations, much bigger space structures in orbit that might be the future of a life in space for commuting, for science, for Hollywood, for entertainment.
What are the biggest near-term opportunities?
One of the things we're most excited about right now is AI data centers. This is special because we know that we're going to have this growth in compute on Earth, but there's a really significant carbon footprint to doing that work here. They're starting to struggle a little bit getting water permits, being able to have the land that they need. So one opportunity is to think about these new installations for AI servers in space. Now, it's not because it's cold, it doesn't quite work that easily, but it is an opportunity to get direct, unfiltered sunlight to power these really massive data centers.
What are the obstacles to doing that? It sounds like an ideal solution. Why haven't we done it already?
Partly is the cost to get to space, but the amazing thing is in the last 15 years, the cost to get mass to orbit has dropped orders of magnitude. So all of a sudden, really large-scale infrastructure, what we like to say at Aurelia is we work on space infrastructure for the public good, is now feasible because the costs have come down so much.
So talk a little bit more about that in terms of practical things that you might be investing in. What does that look like? What are you actually putting money into?
So from a day-to-day basis, we're investing in this technology called Tesserae. It's my MIT PhD in self-assembling space architecture. So how do you build something bigger than your biggest rocket? It's got to be modular. Think space Legos. So we've just invested in a company that we're spinning out of the Aurelia Institute ecosystem, invested in by the Foundry Fund, called Rendezvous Robotics, and they announced a partnership with StarCloud NVIDIA.
Cool. Okay, so how soon could we see these things happening?
So we've already tested the Tesserae self-assembly tech in orbit twice. We're doing our next orbital test in July off of the International Space Station, and we think we'll do a free space demonstration of this self-assembly either the end of 2026 or 2027. That feeds you right into, prior to 2030, being able to have prototypes at least of an AI data center in space.
That's pretty exciting. Talk about the climate impact. What does this actually mean in terms of how it could reduce some of the impact on Earth?
So when you have really concentrated computing infrastructure, like what you need for a data center, it throws off a lot of heat. That's heat that's being, when it's installed on Earth, thrown off under the atmosphere. So it really contributes to some of that carbon footprint, some of the heating that we don't necessarily want to see. But we do want to see AI be able to scale up and serve the needs of consumers and really improve life on Earth. So the opportunity is to take that physical infrastructure burden and put that work into space, get it above the atmosphere.
They're big data centers.
They
Space
are.
is getting crowded. How do you solve for that?
It's a great question. Space is really vast. People see those diagrams of all of the Starlink satellites, for example, orbiting in space. There is actually ample room in orbit for this kind of technology. What's important to us at the nonprofit side of my org at Aurelia Institute is that we're thinking intentionally about not contributing to space debris. So in 2018 or 2019, the FAA, organization in the US, basically said, you can't launch new things to space unless you can prove it's not going to become debris. So we're held by that standard. The companies doing AI data centers at scale will be as well. And so that's really important to us, that we don't contribute to that crowdedness or the debris problem in orbit.
And is everybody signed up to that?
Everyone that launches from the US is bound by it, and fortunately for us in our industry, the vast majority of players are launching from the US. We can't necessarily enforce the same rules on China or other polities, but certainly anybody launching from SpaceX, for example, is going to be bound by that.
So if we get this right, what does a mature space orbital infrastructure look like in like 15, 20 years? How did AI data centers, also solar, the other things that are going on, all fit in?
We want to see a near-term vision, exactly in that timeline that you just identified, of space infrastructure for the public good. So it's not just AI data centers, it's space-based solar power. You can capture raw, unfiltered sunlight, beam it to Earth 24/7, solve the intermittency problem for solar power. We're really excited about the future of biotech in orbit. Much bigger factories, so way bigger than the International Space Station, where you could actually do new cures for cancer, tissue engineering to cure blindness in a way that you can't do on Earth. I did my PhD at MIT, and as a scientist, I'm so excited about this potential to really leverage space for Earth.
I love it. I could spend all day talking to you,
so
Ariel. Thank you so much for stopping by.
It's a pleasure to
the
meet
Hub
you.
Culture
Thank you so
outdoor
much.
studio outside our own, kind of looks like a space.
It does. It looks like
Right?
a space pod. It's fabulous.
All right, thank you so much.
Thank you so much.
Stay in touch. Let us know how it's
Will
all
do.
going.
My pleasure.